In this video, we shall show how to use the combination formula to expand a binomial x plus y raised to a positive exponent. Example 2.32, applying binomial theorem to expand x plus y raised to n. Write the binomial expansion. I chose to start with this because I just want you to see again the special product for a plus b raised to 3. This is often listed among your special products. And so just in case you cannot recall your special product, well, you can write it in this way and use the combination formula to find its binomial expansion. So this is how you read it. Summation of 3 taken r ranges from 0 to 3 times a raised to 3 minus r times b raised to r. So some students cannot recall how to write the exponents. The exponents should be written in such a way that the sum of the terms or the sum of the exponents of the terms should be equal to the degree of your polynomial. I'm talking about the binomial a plus b, okay? A plus b or x plus y. So this is what you can do. You can write it term by term. And just like what I told you, you can do what I do here. I don't write it term by term. Instead, I write the combination symbol one by one and also with the literal coefficients one by one. So I'm going to show to you how I do it. So be sure to leave a space. Okay, so be sure to leave a space because you still need to write the terms of your binomial. So let's now show the value of each of the terms of our expanded binomial. So this is your special product. So I hope that you can see now that you can obtain the special product of a plus b raised to 3 using your combination formula. Okay, so let us show it again. Why is 3 taken 0 equal to 1? So using your combination formula, this is so that's it. These are the values of our numerical coefficients. 3 taken 0 is 1, 3 taken 1 is 3, 3 taken 2 is 3 again, and 3 taken 3 is 1. We are still with the cube of a plus b, but this time we shall modify it. We shall turn it into a minus b. Again, our purpose here is to confirm your special product. So I can remember my days in college, I had difficulty remembering what ought to be the signs of your terms in your expanded binomial. This is what you can do. You can write a minus b as a plus the negative of b and then raised to 3. And then you will apply your binomial theorem. But you must not remove the sign of negative b. It's a plus the negative of b. Okay, look at that. So instead of just b, it's the negative of b. Negative b raised to 1. And you know what it will do to this sign. It's going to turn it into minus. This one is just negative b raised to 2. All of that is positive. And you know what the power will do to negative 1. This is negative b raised to 3. So this one will be minus. So that's it. A cubed minus 3a squared times b plus, okay? Because this is squared and then minus again. Expand the binomial 3x minus y raised to 5. Obtain the binomial expansion of 3x minus y raised to 5. Write it in terms of addition. 3x plus the negative of y raised to 5. This is the compact form of your binomial expansion ought to be. Using your summation, look at this. What are you raising to 5 minus r? It's not just x. It's the whole quantity 3 times x. That's why you must put it in your grouping symbol. It's the same with the second term of your binomial. You are not raising to 5 only y. It's the whole of negative y that you will raise to r. Again, the pattern is, if you were to add the exponents of the terms in your expanded binomial, it should be equal to the degree of your polynomial. So this one should be 5 minus r plus r. That's 5. This is the expanded form of your binomial raised to 5. And let me show it again how I will do it. You can write this term by term, or although it's easy to get lost, but you can copy what I do. Okay, so let us again pay attention to our pattern. Look at our exponent for the first term. It is written in descending order of exponent. 5, okay, 4, 3, 2, 1. And then you have here 3 to the x raised to 0. And then your second term is written in ascending order of exponents. So you have here something like negative y raised to 0, which is just equal to 1. And then negative y raised to 1, to 2, to 3, to 4, and then to 5. It's not just y, it's the entire negative of y which is raised to your exponent. Doing it that way will mean a big thing. It will mean a big difference. So you ought to be mindful about those things. Okay, so let us now simplify this. So this one, well, it's easy to show for 5 taken 0. Let us show, for example, 5 taken 2. 5 taken 2 is supposed to be equal to 10. So let us show it. Okay, so 5 taken 2 is equal to 10. And then, how about 5 taken 4? Okay, so let us show 5 taken 4. Look at this one. So 5 taken 4 should be equal to 5 again. Okay, so let us show it. Okay. Now, let us now pay attention to how we simplify your terms raised to an exponent. Look at this. 3x, the quantity 3x raised to 5. So it's not just 3x raised to 5. It should be 3 to the 5. 3 to the 5th power times x to the 5th power. It's the same with this one. Look at what will happen here. This one is negative y raised to 1. So this one will affect your operation. It's going to be minus. Look at this term. This is negative y raised to 3. Negative. And raised to an odd exponent. You know what that exponent will do to negative. It will retain the sign. And it will affect that operation. It's going to be minus. Okay, look at that. Look at that. Minus. So the rest is just arithmetic computation. And if your teacher will allow you to use your calculator, this is just straight using your calculator.